Hi guys, welcome to Object-Oriented Programming in C++. Here we'll learn how to program in C++, keeping the object-oriented principles in mind. We'll start off with the assumption that most of you have some basic syntax knowledge of C++ along with some concepts of procedural programming. Just to understand what's the difference between object-oriented programming and procedural programming. If you do not, then please don't panic. We'll cover all of them as we proceed along. So let's get started. In today's tutorial, we just talk about the process of language translation. No code involved, just some theoretical concepts of learning what happens to our source code and how it's converted to an executable. So, starting with language translation. Okay. Now the source code that we write is basically somewhat in English, and the computer doesn't understand English. So what it does understand is a series of binary instructions, which is called an instruction set or a machine language, which is somewhat like this. Okay. So this is very short one, but kind of what an instruction set looks like, which the computer understands. So it isn't, as you can see, it isn't binary, it's in 1 zeros, and it's really difficult to program in this language. So we came up with a set of languages called the high level languages, which are easier to code in and provide a better abstraction, but at the end the source code that we write in a high level language has to be converted to machine instructions, that is in this form. So in a nutshell, every source code that we write has to be converted to machine instructions. And what helps in doing that is called a translator. Conventionally, translators are of two types. One is an interpreter, and the second one is called a compiler. So let's talk about the interpreter. An interpreter is a computer program which converts the source code into an intermediate language and immediately executes them. So for example, if you have a program which contains 2 lines of code, it will first convert the first line into an intermediate language and then execute that. Then it converts the second line and then executes it. An example of an interpreted language would be BASIC. So basically the programs that we write in BASIC are converted line by line and they are executed simultaneously. After each line is converted, they are executed. Now there are various advantages of using an interpreter. An interpreter requires that the entire program, the entire source code that you write for a program be available when it's translating. So it can actually pinpoint the errors, be more specific about where the error has taken place. And also the transition from source code to an executable is pretty fast because you are immediately executing them. So the transition is pretty fast. So that's about the interpreters. Before going to the compiler, let's talk about one major disadvantage of the interpreter. Since it is required that the entire source code be available to the interpreter before during translation, it gives rise to serious space limitation issues while dealing with large projects. So that's one major drawback of an interpreter. Now let's talk about the compiler. Now in case of a compiler, the entire file is converted into an intermediate language. That could be a machine language or an assembly language. So the entire file is converted and then that file is executed. So the programs generated by a compiler tend to be more, they require much less space and they run more fast. But the major advantage of using the compiler comes in case of when we are building large projects. The disadvantage that we had with the interpreter while building large projects was that the entire source code had to be available to the interpreter to translate. But because in compiler every file can be compiled independently, that disadvantage is no more. So each and every module or each and every file can be tested independently, and they can be linked together with the help of a linker and create an executable. Also, if there is some module which could be used or rather reused by another programmer, it can be made into a library, and which helps us from reinventing the wheel again. Now we'll just skim through some basic syntax in C++. Let's start with function declaration. I know it's hard to start with function declaration, but they are the most important part. So a function declaration in C and C++ gives the function name, the argument type passed to the function, and the return value of the function. So here's an example: int func int comma int. So this is a function with the name function, which returns an integer and takes two integers as inputs. And say if a is an integer, and you say a is equal to func 2, 3, then whatever the result is of this function gets stored in a. Remember that a has to be compatible with the return type of the function. So this is about function declaration. Now one very important thing to remember in case of a function declaration is, if you write a function with no arguments, say in func, in C it means a function with any number and type of arguments. So there could be any number of arguments of any type in C, but in case of C++ it means a function with no argument, because it prevents type checking, and which is an integral part of C++. Now if you add a body to this function, it becomes what's called a function definition. A body is a collection of statements enclosed in braces. So now let's talk about variable declaration. Now there is a lot of confusion between variable declaration and variable definition. Both of them are different. When you declare a variable, you say that, okay, you haven't seen this variable before, but it exists somewhere in the program. In a function declaration, you give a type, the function name, the argument list, and a semicolon. That's enough for the compiler to figure out that it's a declaration and what the function should look like. So in the case of function, this was a function declaration. You declared the function and told the compiler that this is how the function func should look like, and this was the function definition, when you define the body of the function. So this is the difference between declaration and function. But now when you declare an integer, say int a, there is enough information available for the compiler to create space for the integer a. So this is both a declaration and a definition. But when you don't want to define the integer but only declare it, that is, you do not want the compiler to allocate space for this, that is when you use a keyword from the storage classes, which is extern. It just tells the compiler that the definition is external to the file, or that the definition occurs late in the file. Now this extern keyword can also be used with functions. To just make it more clear, we'll just go through some examples. Say we have extern int q. Now what could this be? This is a declaration without a definition. Say if you have extern int w, int. Now this is a function declaration, just a declaration, not a definition. Now say if you have int a, this is both a declaration and a definition. Now this is a definition of this declaration. Please note that W is a function here, not a variable. So this is a definition of this declaration. Now this is again a definition of this declaration. Now this is both a declaration and a definition. I hope it's clear by now that what's the difference between a declaration and a definition. When you declare, you just declare and tell the compiler that this is the declaration and this variable or function might be exists somewhere in the program. And when you define, you allocate the necessary space for it. Now an important part of programming is not to reinvent the wheel. So there's a lot of work been already done which you would not like to do it from scratch. There are a lot of functions which have been written previously and which are ready to use. So these are called libraries, and these libraries can be used directly by using an include statement. So most libraries contain significant number of functions and variables. To save work and ensure consistency when making the external declarations, in C++ we use header files. A header file is a file containing the external declarations for a library. So to include a header file, we use the hash include statement followed by the header file name which goes here. You must have heard of iostream. Now this statement causes the preprocessor to search for the file in a search path which you include in your environment variables. Now if you remove these angle brackets and put double quotes, it tells the compiler to search for this header file relatively, that is in the current directory. If it does not find the file in the current directory, then it goes to the default search path which you have mentioned in your environment variables. Now let's create our first program, the Hello World program, and look deeper into how we create it. So we would like to use the iostreams class which contains a lot of input-output libraries. So to include that, the header file, we will write the statement hash include iostream. The iostream package automatically defines a variable called the cout that accepts all data bound for standard output, which is our console. Now to send the data to the standard output, we use this operator. In C, if you're familiar with C, this is known as the left shift operator, but in C++, because C++ supports operator overloading, we overload this operator to use it in standard output. So we will be using this operator to print in our program. Now one of the problems that was encountered in C was is that we were running out of names. Say we had a big project and a lot of programmers were working on it. Now everybody will have to be careful of not using a variable name or a function name which some other programmer has already used. So the problem is that people were running out of names. Not actually running out of names, but running out of meaningful names. So it was actually annoying to think a proper name after some time in a very big project. So in standard C++, we have something called the namespaces which help us in avoiding this problem. Each set of C++ definitions in a library or program is wrapped in a namespace, and if some other definition has an identical name but is in a different namespace, then there is no collision. So to include a namespace, we use the using keyword, and namespace tells that it is a namespace, and this is the actual name of the namespace. So it is std, which has our input and output, which has various functions and header files in it. We all know that C++, the compiler starts with our initialization function called the main. The execution starts here. Now the cout object is handed a series of arguments via this operator, which is the left shift operator in C, and this is a string that we are passing into the cout object, which is printed on our standard output, and this is just to add a carriage return at the end. Now save this file as hello.cpp. Do not forget the .cpp extension, which tells the computer that this is a C++ file. Now guys, open the command prompt and go to the location where your file is saved. I've saved it on my desktop. So here's what we're going to type: g++. Ensure that g++ is installed on your computer and is configured in your default search path. You can add it by going to the environment variables in your computer properties. Just see online on how to add that. It's pretty easy. So I'm just going to continue. If g++ is not installed on your computer, it will say that g++ is not a recognized command. But if it is installed, then it will give an error saying that there is no input files. So now giving an input to this g++, the name of our file was hello.cpp. Now what this does is it compiles the file and gives us an object module, which is the executable here. So we have our executable, and by default, since we have not given any name as to on what name the executable has to be saved, so by default it is saved as a.exe. If you check the location where you have stored your source code, you will see an executable with the name A. So just run that and you can find the output of our program. Now similar to standard output, there is a standard input as well. The object used for standard input is cin, that is CIN. CIN normally expects input from the console, but this input can be redirected from other sources. We will look at one example later as we proceed along. So let's put that to test. Say there's an integer number, and this is the standard input object, and this is what we use to push our input. So just say cin number, and we'll print our number here, number. So this should take in an input from the console and print it again. We'll check it here. So let's compile that again, and let's just try it. We gotta save the file first, so save it, and now let's compile a new program. Right, we have to give the input now, so we're giving the input as 7, and you see, hello guys, and the number is printed. Now let's talk about strings. If you're familiar with C, you would have known that we don't have strings in C, but we rather have character arrays. Though they are very useful, but they are quite limited. So the size of a quoted character array is fixed at compile time. So if you have a character array and you want to add some more characters to it, we have to go through a lot. We have to have a good understanding of dynamic memory management, character array copying and concatenation before we can add more characters to it. So the standard C++ string class was designed to take care of all the many low-level manipulations of the character arrays that were previously required of the C programmer. Though we will be talking about this string class in the later tutorials, but it is very important. So we'll just have an introduction of the string class, and then we will dig deeper into the string class later on. So we'll start out by writing a small program. Here we'll first define two empty strings. String, say s1 comma s2. So these are two empty strings. We'll define two more strings. String s3, say hello, and string s4, world. Now these two are empty strings, while these two s3 and s4 are initialized strings. Now before all of this, now all of these are defined like iostream. We have a string, a class in which all the string manipulations are defined, so we need to include that so that we could use them. Now if we say we wanted to assign something to the empty strings, we will just use the equal to operator, assign something here written here, and s2 again some blah blah. Alright. Well, there is another way of initializing the string. We could just do so by, say if we want to change this for while declaring itself, we could do like this. So this also initializes the strings. Now let's print all these strings. Let's save this. This is the same file, so we're gonna compile it. Run this thing. So you see, we are now printing all the strings. Now let's do some manipulations on the strings. Say we want to combine two strings. We just use the plus operator for combining two strings and assign it to another one. So here s1 is equal to s3 plus space plus s4. Say we want to concatenate a string, we just do it with the plus operator, and take the string which we want to concatenate and add a plus operator between them. Say we want to append two strings, we just take the string, again a plus operator, and the string that we want to append to. So let's see if the changes have taken place in our program. So we first need to compile our program. And see here, the changes have taken place. The big blah has come. Alright, so moving on. Now let's move to a topic which is introduced very late in C. Because in C the process of opening and manipulating files requires a lot of language background to prepare you for the complexity of operations. However, the C++ iostream library provides a simple way to manipulate files, and so this functionality can be introduced much earlier than it would be in C. To open files for reading and writing, we must include the fstream header file. Although this will automatically include iostream, it's generally prudent to explicitly include iostream if you are planning to use scene and cout. To open a file for reading, we create the ifstream object which behaves like cin, and to open a file for writing, we create the offstream object which behaves like cout. So once we open the file, we can read from it or write from it just as we would do with any other ifstream object. It's very simple. So one of the most useful functions in the ifstream library is getLine, which allows us to read one line into a string object. So let's write a program which copies one file to another file, just to understand how this opening and writing, reading and writing files thing works. So then we create the ifstream object here, and we give the file name which we have to read. Currently I've created a file as input.txt. Just to see what input.txt contains, this is our input.txt, which is basically trash. So let's create another offstream object, and let's pass the name of the file which has to be copied into. So we basically take the input from input.txt and copy it into output.txt. Alright. Okay, so now the logic here, string s while I know while condition is not been introduced yet, but we will talk about it now as on an introductory basis. We'll get into it in the next tutorial detail. Alright, so now let's save this thing. Now one thing that you must know is that as long as there is an input in the input.txt, this loop will continue to give, this thing will continue to give true value till it reaches the end of the input. So everything that is copied, everything that is there in input.txt is copied to output.txt. So let's run this thing and see if that works. Okay. Now if you can open the current directory in which you are and see that there is an output.txt file which contains this everything that input.txt contains. So this is about copying the files or manipulating the files. So with strings, we can fill up a string object without knowing how much storage we are going to need. Now the problem in this program that we wrote was that we did not know how many strings will be there in the input.txt. So we had to write this logic. In many cases, we do not know the number of strings that can be used. So we cannot create a proper container to put all those strings in. So in C++ we have another holder which we call the vector, which we will talk about here. So this vector object automatically expands or shrinks itself. In fact, why limit ourselves to holding string objects? It turns out that this kind of problem, not knowing how many of something you have while you're writing a program, happens a lot. And this container object sounds like it would be more useful if it would hold any kind of object at all. Fortunately, the standard C++ library has a ready-made solution, the standard container class. The container class are one of the real powerhouses of standard C++. Now the vector class is a template, which means that it can be efficiently applied to different types. So we can create a vector of any data type, a string, an integer, a character, anything, even of the user-defined data type. Now to tell the compiler of what data type we're gonna create a vector, we put it in angle brackets. So if we say vector string in angle brackets, we're creating a string of vectors, vector of strings. Now let's talk about some functions that are available from the vector class. To add a brand new element at the end of the vector, we can use the member function pushback. There is also an insert member function to put something in the middle of the container. Vector supports this, but its use is more complicated and we won't need to explore it until we deal with it specifically. There is also a push front to put things at the beginning. So we'll write a program here which reads from a file and outputs it to the console. So let's get cracking. Right. So let's create a vector of strings. Vector string B. Let's create a stream object so that we can read from a file. Say we'll continue with the same file that we have. And don't forget to put it in the apostrophes. Input.txt. Now we'll create another string line which will help us in printing what we're reading from the input.txt. This is the logic of the program. Get line, the stream object, normal line. Pushback. Pushback is the member function in vectors which helps us in pushing at the back of the vector. So for is not introduced yet, but go along because we will talk about it later. We got size. Alright, now we wish to print it. Cout I. Let's put some design into this. And what will we print? Let's say we are printing just print it. Alright, so let's save this thing and let's compile this. B++, it's the same .cpp file. Okay, before we use vector we need to include the we have some errors. Yeah, so before we compile this we need to include the vector header file so that the compiler knows that there are certain member functions from the vector header file that needs to be included. So now we compile it. Hope it should run now. Yeah, it does. Now run this thing. And yeah, so because in our input.txt we gave two carriage returns first, so it's not printing anything here. See, this is how our input.txt looks like. Alright, now this program is much similar to the one which we wrote earlier, but in that we had two files. We were reading from one file and copying it to another file. In this, when the for loop completes, when this loop completes, the entire file, the entire input.txt is inside the memory. This could make a difference in a lot of problems that we might have to solve. I'm just assuming here that you know something about the for loops and the while loops. Alright guys, this sums up our first tutorial. We'll talk more about functions and control execution in the next tutorial. So until then, stay safe and keep coding. Alright, bye guys.